At 7,000 meters below the ocean's surface, in a world of crushing darkness and bone-shattering pressure, something moves through the void. It has no eyes. Its body is transparent. Its mouth unhinged to swallow prey twice its size. And it glows in the dark. This isn't science fiction. This is the deep sea. And the creatures that live here look like they were designed by a committee of horror movie directors having a very bad day. But here's the thing. Every bizarre feature, every nightmarish adaptation, every weird characteristic exists for a reason. These aren't monsters. They're masterpieces of evolution, sculpted by the most extreme environment on Earth. So why do deep-sea creatures look so weird? The answer is written in their bodies, a biological blueprint for survival in hell. To understand why these creatures look the way they do, you first need to understand where they live. The deep sea begins about 1,000 meters below the surface, deeper than the Empire State Building is tall. But most deep-sea creatures live much, much deeper. Some inhabit trenches that plunge to 11,000 meters, nearly 7 miles down. And at those depths, the environment is hostile beyond imagination. First, pressure. At the surface, you experience 1 atmosphere of pressure, about 14.7 pounds per square inch. At 7,000 meters, pressure reaches 700 atmospheres. That's enough to crush a polystyrene cup to 1/3 its normal size. It's equivalent to having 1,600 elephants standing on your head. Second, darkness. Sunlight penetrates only about 200 meters into the ocean. Below that, it's perpetual night. At 1,000 meters, the edge of the deep sea, light has completely vanished. You could have the world's most powerful spotlight, and within meters, it would disappear into the void. Third, temperature. While surface waters can reach tropical warmth, the deep sea hovers between 1 and 4 degrees Celsius, just above freezing. Your refrigerator is warmer than most of the deep ocean. And finally, food. In the sunlit surface waters, photosynthesis fuels an explosion of life. But no sunlight reaches the deep. Only about 5% of organic matter that starts in the surface zone makes it to the abyss. Down here, every meal could be your last. Finding food is a desperate, constant struggle. This is the world deep-sea creatures call home. And every single, weird, feature they possess is an answer to these challenges. Let's start with pressure, the force that should, by all rights, crush these animals into paste. Surface fish have rigid skeletons, dense muscles, and swim bladders filled with gas to control buoyancy. But take that fish to the deep sea, and it's a death sentence. The swim bladder would collapse. The skeleton would offer no protection. The body would implode. Deep-sea creatures evolved a radical solution: become soft. Many deep-sea fish have gelatinous, almost jelly-like bodies. Their bones are thin and flexible, some barely ossified at all. They lack swim bladders entirely. And here's the key: they're filled with water, not gas. Water is incompressible. The water inside their bodies exerts pressure that equals the water outside. They're in equilibrium. No pressure differential means no crushing. But there's more. Scientists discovered that deep-sea creatures produce high concentrations of a molecule called TMAO, trimethylamine N oxide. This compound acts like a molecular bodyguard, protecting proteins and enzymes from being distorted and destroyed by extreme pressure. The deeper you go, the more TMAO you find. It's nature's pressure suit, built at the cellular level. And that's why so many deep-sea creatures look soft, flabby, and almost deflated when brought to the surface. They're not damaged. They're simply designed for a world where being squishy is a superpower. Now let's talk about eyes. Or more accurately, let's talk about the bizarre ways deep-sea creatures have reinvented vision for a world without light. Some deep-sea fish, like the barreleye, have enormous tubular eyes that point straight up. These eyes are so large they account for a significant percentage of the fish's body mass. Why? Because they're essentially biological telescopes, evolved to detect the faintest traces of bioluminescent light from creatures above them. The barreleye's eyes are encased in a transparent, fluid-filled dome on top of its head. This lets the eyes rotate to track prey while keeping them protected from the stinging tentacles of jellyfish, the barreleye's primary food source. Other creatures, like the dragonfish, evolved a different solution. Most bioluminescence in the deep sea glows blue or green, wavelengths that travel best through water. But dragonfish produce red light. Here's the clever part. Most deep-sea creatures can't see red. It's invisible to them. So the dragonfish essentially has a built-in infrared spotlight, letting it hunt prey that can't see it coming. And then there are creatures like the Mariana snailfish, which live at the absolute bottom of the ocean, the deepest fish ever discovered. At those depths, there's no light at all. Not even bioluminescence makes it down there. So the snailfish did something radical. It gave up on eyes entirely. Genetic analysis shows these fish have lost key photoreceptor genes. They're functionally blind. Why maintain expensive biological equipment you'll never use? Instead, they navigate by sensing vibrations in the water, detecting chemical signatures, and using a sophisticated lateral line system. Essentially, they feel their way through the darkness. In the deep sea, finding food is so difficult that evolution produced some of the ocean's most horrifying feeding strategies. The anglerfish is the poster child for deep-sea weirdness. That glowing lure dangling in front of its face? It's actually a modified spine packed with bioluminescent bacteria. The anglerfish doesn't make the light itself. It farms bacteria that do. The lure mimics the movement of small prey, attracting curious victims. And when something gets close, the anglerfish strikes with shocking speed, its enormous jaws lined with needle-sharp teeth that angle backwards. Once bitten, there's no escape. But here's what makes the anglerfish truly bizarre. The males. Male anglerfish are tiny, sometimes just a few centimeters long, and they have one purpose: find a female. When a male finds a female, he bites into her side and fuses with her body. His bloodstream merges with hers. He becomes a permanent parasite, providing sperm whenever she needs it. Some females carry multiple males fused to their bodies, creating a grotesque living reproductive system. Then there's the black swallower, a fish that can eat prey twice its length and 10 times its mass. Its stomach is so distensible it can expand like a balloon. Sometimes these fish eat prey so large they can't digest it before it starts to rot, producing gas that floats the fish to the surface, where researchers find them bloated and dead, but still proof of their incredible feeding ability. The gulper eel takes a different approach. Develop a mouth so large it's basically a living net. Its jaw can open wider than its body is long, creating a cavernous trap that scoops up anything unfortunate enough to swim into it. These aren't just random mutations. This is precision engineering for an environment where you might go months without eating. So when you encounter food, you better be able to consume whatever size it is. When food is scarce, the best strategy is to use as little energy as possible. Deep-sea creatures have mastered the art of slow living. The Greenland shark, which can dive to depths of over 2,000 meters, has one of the slowest metabolisms of any vertebrate. These sharks grow just 1 centimeter per year and don't reach sexual maturity until they're about 150 years old. Scientists estimate some Greenland sharks may live for 400 years or more. They move so slowly through the water they're almost stationary. They don't chase prey. They're ambush predators that wait for food to come within striking distance. Every movement is calculated, every calorie conserved. The giant isopod, a deep-sea relative of the common pillbug, can go years without eating. Years. When food finally arrives in the form of a whale carcass or large fish, they gorge until they can barely move, then return to a state of near hibernation. Many deep-sea creatures have metabolic rates just 10% of their shallow water cousins. Their cold-blooded physiology combined with near-freezing water means their bodies require minimal energy to function. They've essentially entered a state of living suspended animation, existing in a metabolic slow lane where time moves differently. This is why so many deep-sea creatures appear sluggish, strange, and alien. Speed and agility are luxuries reserved for environments rich in food and oxygen. In the abyss, stillness is survival. So here's what we've learned. Deep-sea creatures don't look weird because they're mistakes or evolutionary dead ends. They look the way they do because they've been shaped by the most extreme selective pressures on Earth. Every transparent body, every enormous mouth, every bizarre reproductive strategy is a solution to a problem that would kill any surface creature within minutes. And studying these adaptations isn't just academic curiosity. The compounds deep-sea creatures use to survive pressure, like TMAO, are being studied for applications in medicine, including treatments for protein-folding diseases like Alzheimer's. Bioluminescence research has led to breakthroughs in medical imaging and cellular tracking. The enzymes that function under extreme pressure are being explored for industrial applications. But there's a darker reality. The deep sea, which we once thought was too remote to be affected by human activity, is changing. Climate change is altering deep ocean currents and oxygen levels. Deep-sea mining threatens to destroy ecosystems we've barely begun to understand. These creatures evolved over millions of years to thrive in stable, extreme conditions. But they're not adapted to rapid change. And we're creating that change faster than evolution can respond. We've explored less than 5% of the ocean floor. We've cataloged only a fraction of deep-sea species. And already, we're disrupting their world. The deep sea is often called Earth's final frontier. It's one of the last truly wild places, a realm where creatures we can barely imagine have carved out existence in conditions we cannot survive. Yes, they look weird to us. But weirdness is just another word for unfamiliarity. To a deep-sea fish, you would be the bizarre one, a creature that requires constant light, can't withstand pressure, and lives in a thin skin of water at the edge of space. These creatures aren't monsters. They're survivors. They're evolutionary artists painting with the colors of adaptation in the darkest canvas imaginable. And they remind us that life, relentless, creative, impossible life, finds a way. Even in the places we thought nothing could survive. Even in the dark.